Hey everyone, thank you for the intro, Andy, and for having me for the third time here, I think, and an epic FEL as well. So I don't know why he's still putting up with me, but he keeps letting me come along, and I keep talking about JavaScript, hopefully without boring people too much. So yeah, my name's Jack. That's me on Twitter. I work for a company called Pusher. I'm interested, who's heard of Pusher? That's pretty good. That's my job done for the evening. For those who haven't, we're like a hosted real-time platform. Come and chat to me about Pusher. I'm not here to talk about them. What I'm here to talk about is actually my old company. It's one of my colleagues whom is sat in the audience. So I used to work for a company called GoCardless. Who's heard of GoCardless? It's not going to be every slide. OK, more people have heard of GoCardless, so I've made a dreadful career move. But anyway, so this whole story started, and the reason this talk came about was we had to rebuild this website. So GoCardless is a payments provider, and at the time we were based purely in the UK, and we only served UK businesses. That was fine. So the GoCardless kind of, what I would call these the splash pages, the static site, was a Jekyll build. And it was all in English because we only served the UK, and that was easy. We just generated some HTML and threw it onto the internet. But then we launched in France, and we needed a French version. So we needed actual French pages. So we did what every good developer does and copied the folder, made another one called France, and got the people who speak French in the office, which is not me, to make the French version. And that kind of worked just about, duplication is OK once and all the rest of it. And then we needed to launch in, I can't remember, Germany, wherever it was, another language, basically. And we couldn't quite bring ourselves to do it 3 times, although it was quite tempting. And we started thinking about what else we might instead do. And we needed to build a framework to kind of let us manage all these multiple languages on the site. Additionally, this site, this is the whole GoCardless site. So there's all about our product, but there's also things like the jobs pages about us. So we needed not just engineers to be able to edit this stuff. Ideally, this should be editable across the whole company. And at the time, there was this little library called React floating around. And we kind of used this as a bit of an excuse to see if we could build a React application that would run all the splash pages for GoCardless. This would let you use, we'd have a French version and so on and so forth, but we build it as a kind of a JavaScript framework, if you like. But of course, we didn't want GoCardless to be a massive JavaScript application that wasn't accessible. There was no need for it to be a JavaScript application, although these days everyone is doing that. And we started to look at how we could write React on the server as well. React does come out of the box with server-side support. That means you can run React in, say, a node environment and just get it to spit out strings of HTML for you. And that's really where we started from. The website launched. I can't remember how long ago it launched. It was quite a while ago. It's been out a while. Obviously, I've not been there for a while, but I'm led to believe it's still doing a good job and still plugging along. And it's a really nice experience because if you visit it without JavaScript, you get the website because it comes from the server. If you happen to have JavaScript loaded for whatever reason, then you get the full JavaScript experience. It's all loaded in the page, so every click is incredibly snappy because you're just swapping out bits of content basically using React. If you load it and then you lose connection or your JavaScript doesn't load, you click a button, it just goes back to the server again. So it's a really nice experience for all, really, and why we really bought into it and why I bought into it. So I'll link to all these at the end, but I wrote a blog post for 24 Ways last Christmas on Universal React, and then from this, the blog post from that blog post, the talk came about. There's a few kind of reasons that we, building JavaScript applications that are 100% reliant on JavaScript is a bad idea. I used to work at GDS as well, along with Sharon, and we did this study, or I say we, someone in the company, but if I say we, it sounds like I was involved, did this study, and on the GovUK website, 1 in 93 or 1.1% of people weren't getting JavaScript. So when they visited GovUK, for whatever reason, we didn't have any JavaScript running. What's more interesting than that stat is that of those 1.1%, only 0.2 were the people who had explicitly gone into their browser and configured JavaScript to be turned off. The rest hadn't got JavaScript for any number of reasons. Their connectivity was bad, whatever, they were in a train, they went in a tunnel, they were on a national rail train, whatever it might be. And this was really interesting to me because I did used to have this kind of gung-ho attitude of, well, if people have turned off JavaScript, then they don't deserve anything. And I still kind of think that might be a little bit true. But most people who are visiting without JavaScript didn't actually have it in the first place, and not out of choice because of their certain situation. And this blog post includes that quote, just only a small slice of people who don't run JavaScript are the ones who have chosen not to. And this kind of comes down to the whole progressive enhancement, and does it just mean if JavaScript is turned off or not? Jake Archibald, in his blog post about progressive enhancement, says it's never been about people who have turned JavaScript off. These greens, by the way, are all links, and I'll put the slides up afterwards. And a guy called Stuart Langridge did this really cool flow chart, which again is linked to at the bottom, which goes through the steps taken from a user hitting like gocarlos.com and it downloading all the files, and at all the points that for some reason a request can fail and therefore JavaScript won't make it to the end user. On a train, there was an incident where Sky, they decided that jQuery from, I think, the Google CDN was a virus and blocked jQuery. Again, might be the best decision they've ever made, but you know, suddenly loads of these websites broke completely because Sky made a mistake. We've had like browser add-ons can mess with JavaScript. There are so many different circumstances in which your JavaScript can partially execute, not execute at all, be a bit or whatever. So it's really important that we deal with that and bear that in mind. A really recent talk from Google I/O, which I've stupidly not put the link to, so you'll have to copy it from the screenshot. Yeah, that was a bit silly of me. This is Adi Osmani talking about progressive web apps across all frameworks. This was literally last week. I just want to put this in there, and I'll mention this again in a minute, whilst I'm going to talk within the context of a React application, because that's what I know and have worked on. This kind of general thinking is spreading across all frameworks as well. So even if you personally are not using React, if you're using something else, I hope that the talk can still be relevant to you. Another thing, just to be clear, I'm definitely not here to advocate building all websites and applications as React applications that are run on the server and the client as well. You have to think about if this is the right fit for you. You know, GoCardless could easily be a server-side application only, and that'd be fine. We found that with a little bit of JavaScript, we could really improve the experience. But this isn't a talk where I'm going to advocate React for absolutely everything. And also, caveats, we're just starting to really get deep into the nitty-gritty of server-side rendering and frameworks and how this plays nicely. So there are a bit of rough edges. I'm going to throw some code at you. Obviously, all the slides will be online. There is also a GitHub repo that has an actual working example. Some of the APIs and stuff are a little bit rough. Like these will probably change over time and be outdated in 6 months or a year or a day. So just bear with me. Like some of the stuff is a bit rough around the edges, but we are kind of really at the boundaries of this stuff. As I said, React paved the way, but we have Ember, have a thing called Fastboot, which is the same idea. You can run your Ember app in a node kind of environment. And Angular 2 has Angular Universal, which is a similar idea too, that you can run these apps away from the browser. And the whole idea here with all of these frameworks is that we can get this not for free, but with very little effort. So the goal here is that you can write your React or Ember or Angular or whatever app and just put a small amount extra effort in to get that server-side rendering for you. And just to give you a link, again, I'll tweet the slides and hashtag it and put it in the Slack group and all the rest of it. But there is a repo on GitHub. There is a branch called FEL, because I've done this talk about 4 times, that has the latest version of all the demos and stuff on them. So if we take a look at a kind of standard React application, in-depth knowledge of React definitely not required for the talk, but we have a component called myApp, and it has a render method. And in that render method, I declare what this component should look like when it's put into the browser. Then we call react.dom.render. We give it the component to render, this myApp tag here, and then we just tell it where to put it onto the page. So in this case, it's going to render that myApp component and put it into the div on the page with an ID of app. And that's the browser side. And then if I want to swap this to a server-side rendered app, I just swap out the React DOM bit to render to string. And that, instead of trying to render into a DOM, into a browser, will just give me a literal string of HTML. And that's it, talk's over. But it's really cool that React gives you all that out of the box, and it is that simple. The key thing to note here is that the myApp bit never changes, and that's the thing I want you to keep in your heads as we go through. And if you start building apps in this way, as little as your application as possible should know whether it's on the server or the client or whatnot. Ideally, we keep it entirely agnostic, and only at the very boundaries do we change where we're going to render it to. Of course, there's a little bit more involved in that. So we can set up like a little Express node server, which just kind of imports this app component. We pull in the render to string method, and then on any request, we just generate our markup and we render. This just renders a template and just renders the HTML. The kind of details of that aren't too important. And that's it. That will spin up a server that does indeed work. And in some examples, you'll see this method, render to string, used. There's also another method called render to static markup that React provides for us. And there's a subtle difference between the two. You should use render to string when you're expecting the HTML that is rendered to be picked up by a React application on the client. Render to string will include some kind of extra attributes in the HTML that will allow the client-side JavaScript to pick it up and work with it. If you know that's not going to be the case, you're purely working on the server side, you're not going to run client-side JavaScript for whatever reason, you can just call render to static markup, and that will give you kind of lean markup, if you like, that doesn't have any of the specific React attributes. And if I take this server and I run it, I just get back this. I think actually this, with the latest version of React, some of these nitty-gritty details have changed, but the idea is the same. This is generated purely from React. So that's a very basic server-side example, but one of the benefits we found at Go Cardless was that we could then take all this code and push it onto the client as well, and those people who did have JavaScript would get just a little bit more of a snappy experience. So then if we start looking at how we can take this client side, we're going to have a shared set of components that are environment agnostic. This is all our React components. We'll have a server rendering step, just that little JavaScript file we saw, that will run on our server. We'll have a similar file that runs on the client, which we'll look at in a minute. And we'll need some form of bundler, like a Webpack or a Browserify type thing that can take all our JavaScript and create a browsered version of it as well. But the real key detail here is the agnostic components. Your React components shouldn't know whether they're on the server or the client. You, of course, can check. The typical check is to check if a type of window is undefined to know if you're on the server or the client. But you should try to do that as little as possible and try and keep all your components plain and without knowledge. And we are going to use Webpack. Some people love it, some people hate it, but in the example I have, we'll use Webpack to bundle. But I'm not going to go into too much detail on that. But the example in the GitHub repo has all this stuff set up, so you can have a look through it. So if we look at rendering on the client, the first thing we need to do is update the actual template that we're using from the server. So my server-side template looks somewhat like this. So the markup here, that's going to be the thing that's generated by React on the server, and this tag will be swapped out by the HTML we generated. Build.js will be the client-side bundle that's pulled in through Webpack. To create my client.js file, all you have to do is write this as if there was no server-side rendering ever. So you just write this as if you're only building JavaScript on the browser. So again, I import what I need. I import my app, and I call react.dom.render. React DOM, its render method is really, really clever. If it calls render and the stuff inside this div looks like the same React app, it knows that, and it will not completely re-render your entire application. So we're not getting the thing where we render from the server, the JavaScript loads, and we then get a big flash of white as the React app re-renders itself. It's clever enough to pick up and know where it is, so it doesn't have to do that. And the important thing here, as I said, I'm going to keep harping on about it, we have the same components on the client and the server. This my app component is the same one on both sides. Very briefly, look at how we can configure the client-side build. You'll notice I'm using quite a lot of ES 2015 features and so on, and also the JSX kind of HTML in your JavaScript syntax that React provides. So we install a bunch of things, Webpack and Babel something else, and Babel something else, and Babel something else, and you keep guessing what you need to install. And you kind of write random config files that might work and they might not work, and they'll be out of date next week, and who knows. But eventually, then you write some more. But eventually, once you get through all this stuff, you're able to run Webpack or whatever you've chosen and get this build out. It's worth noting as well, I'm not going to touch upon how in production I would like minify this and all the rest of it, but this build, as you'll notice, is 690 kilobytes. This is for a Hello World React application. This is incredibly unoptimized. This would be way smaller if I actually bothered to do a proper demo and wasn't such a shoddy speaker. So we've got this far, but so far the components we built have just been like hello world, and there's not much to it. And if you were building an application for real, you'd probably gone a bit over the top doing all this just to render hello world onto the screen. So if we imagine a more interactive component, this component, it might be a little bit small, but basically it's a button that you can click a button and it increments a number by 1 and shows it on the page. And it looks somewhat like that. So I can click and we get the count. If I then disable JavaScript, I can refresh. And although I still get something, so although I can't click obviously because we have no JavaScript, we can still get something onto the page. Now I'm expert at contrived examples, and this is an incredibly contrived example. But what I'm trying to illustrate here is that a read-only experience is way better than no experience for users. I don't think many of us are building that application in production. This is kind of analogous if you think of an app that pulls from an API and puts some data on the screen, then lets you click a button, say delete one of those entries or whatever it might be. You might not be able to replicate all of that without JavaScript enabled. You might be able to with a bit more work, but even if you can just get your list of data rendered without JavaScript, that's way better than getting a blank screen or an error instead. So whilst ideally we are striving for 100% functionality without JavaScript, in reality, sometimes we can't quite get there. And that's absolutely fine. You know, even the read-only view is going to be way better than absolutely nothing. Now, if we're going to start building a proper application, like, say, GoCardless, the one thing we do need to look at is routing. If you're building just client-side applications, you can get away with not bothering with URLs, although you definitely shouldn't. I think we've all taken a URL from a JavaScript app and sent it to a friend, and they've clicked that URL and got a completely different page because the developer hasn't kept the URL in sync. But obviously on the server side, we have to kind of set up URLs. The de facto kind of standard solution for this in React is called React Router. It might as well be kind of built into React at this point. It's very much kind of the winner, if you like. It's a very good library. So the first thing I'm going to do is actually build my proper app. So I'm going to have an app.js component, and this is my kind of top-level component. So I'll have my nice heading, and then this .props.children is where the kind of nested routes will go. So this is like my layout file, if you like, and this is just a placeholder for whichever route we're currently on. Its content will be put there. Again, the kind of nitty-gritty details of routing and React components aren't too important here. Then create an index page, which is just returns this as the index page. I then define my routes. So again, I have this top route called app component, and at this path / I have this index component. And now on the server side, what we need to do is take the current URL that's just been requested, see if we have a route that matches, and render the correct components. Now the API here is a little bit hairy, and it looks, trust me, it does look worse on a projector than it actually is if you actually were to write it yourself. So please stick with me. The other thing is that you'd only ever need to write this once and you can pretend it doesn't exist. So please bear with me. So we need a couple of things from React Router. We need this match function, which is a function that can take a URL and all our routes and decide if they match up. And then router context is the React component that we need to render that will deal with rendering everything else. So the overall code looks like that. Easy. Okay, next. So what we'll do is we'll break that down a little bit. So the first thing I do is I call match. I give it all our routes, and I tell it the location, which if you're using Express on the server is the request.url property. That will do that asynchronously. We then have a callback function which takes an error, redirect location, and render properties. If we've got an error, that means something went wrong, and we should probably return a 500 or something similar, or return the fail whale type page. If we get a redirect location, that means we've actually hit a route that is a redirect, because React Router supports redirects. Finally, if we don't have an error and we don't have a redirect, then we have these render props, which means we've got all the data we need to render and generate our HTML. Render props is basically all the information the router needs to generate the HTML and render the components. So firstly, if there's an error, I just send the error message with 500. You would probably want to do something a bit more polished for your app. Else, if we have a redirect, I'll just redirect with a 302. And finally, if we got to this far, we can actually render successfully. So I'll render my index template again, and I'll call render to string, and I have to use this router context component and pass in all the properties. This isn't really important. This is basically just saying if we get to this stage, I've got all the information I need to render and generate your HTML for you, and this just does it. Finally, if we get past and we get to this last bit, not really sure what happens, let's just 404. Again, you'd probably fail well, or you'd log this to you, so you'd be aware of it as the developer working on it. And this actually completely works. It's pretty dull, but it does work with or without JavaScript. So let's make it a bit more interesting. Let's add an about page. So we add an about page with some really dreadful text on it, and then we add it in as a route, just down here. And then I'm going to use React Router gives us a link component, which is just like a layer on top of an anchor. The great thing about this is it means in a non-JavaScript environment, it will just be an anchor, effectively. And in a JavaScript environment, React Router will kind of hijack the click and progress you through JavaScript. So I'll add a link to the home and about page. With no client-side bundles, this is all server-side, this does work. I can click between them, I get the right content rendered. And as a user, I'm none the wiser. Oh, nice white flash at the end. I'm none the wiser that something is wrong. I don't have JavaScript enabled, or something's gone wrong with my request, or whatever it might be. We can update the client-side generator as well, or sorry, client-side JavaScript. So I just call react.dom.render, and I just render this router component, which comes from React Router. I can talk in much more detail about React Router. There's lots of tutorials online, so I won't go into too much of what's going on here. Then if I regenerate Webpack and I visit it with JavaScript turned on, we get a really nice, it's a bit unclear to see, but these clicks now aren't going to the server, they're just all in my browser. And note as well that React Router is great and deals with things like forwards and back, and it all works for us as you would expect. And this would work, I don't think I include it, but this also works without JavaScript as well. So that's really nice. We're at this point now where our application works pretty seamlessly between JavaScript and non-JavaScript. The final step is kind of dealing with data on the server and the client. A lot of React applications or JavaScript applications generally will make a request to some API, get some data in, probably JSON, and then render that in some form and let the user manipulate it. This is actually something we didn't have to tackle at GoCardless because ours was more kind of a marketing page. We weren't hitting so many APIs, but I've delved into this a little bit more since. This area, if you think server-side rendering is a bit more work in progress, this is particularly work in progress. There's kind of a number of different kind of approaches to this and thoughts going on. So there's lots of unknowns here. I think better solutions or improved solutions will kind of reveal themselves over time, but for now, this is what I've come up with. So the general idea here is we want to be able to fetch data from some API on the server and the client. So if I don't have JavaScript, that request should happen on the server, and we should get the results of it fetching that data and rendering it into my HTML. However, if I do have JavaScript enabled, the server should still make the request, but then when I come back into my browser and everything's rendered, I don't want the browser to then remake that same request within kind of a second of the server doing it, because that's just a complete waste of time. So what we really want to do is avoid making the request again, and that's where this gets a little bit tricky. There's a number of libraries out there. I've come to really enjoy one called React Resolver. This again is a link. The general idea here is we have a component, so just look at this top bit for now, and this component renders some information about someone from GitHub. So I reference this.props, which is kind of properties you can give a component, some extra information, .github, which will be the data I've got from GitHub, and then public repos is one of the keys that GitHub provides you. It just tell you how many repositories you've got that are public. What I can then do is down here, I can use React Resolver, which is where this resolve function comes from, to say the GitHub prop that I want defined on this component should be the result of fetching this URL and then returning the data from it. So React Resolver lets us basically say this component needs this data from some API. And then on the client side, what we do is instead of using React DOM.render, I use resolver.render. On the server side, it's a little bit more involved. But I resolve, and then we do some extra stuff. So basically, we're resolving. We use React Router to render everything. The key thing here is now I've got this data. I need to spit out my HTML that I've just generated, that this has generated for me, or sorry, this render to string call here. But I also need to pass the data from any API request down to the client. Because if I don't do that, the client can't reuse that data and is going to have to make the request all over again. And then my template, I add this extra property called React Resolver Payload, and that's going to be any data the server had to fetch from an API. So we update the server-side rendering to spit out this payload. We update the client-side rendering to use React Resolver. All data gets resolved on the server by default. It's rendered, and it's then used to populate the data on the client side as well. So React Router will kind of set this, React Resolver will set this property to all the data it got. Then when the client runs in the browser, it can see that this exists, and it can use data from that rather than having to remake all those requests to an API. And now this definitely works with and without JavaScript. So see, I've not made any extra requests here, and I've still got over here my GitHub repo count 201, that is actually coming from the API. You're going to have to trust me on that. But with and without JavaScript, we do get the full application experience. So I appreciate that was quite a lot of stuff to throw at you in quite a short space of time. I was quite relieved to see the previous two talks didn't have lots of code, else you'd be way fed up of all this by now. That's a link to GitHub. It's just that repository, basically. If you have any questions after, I'm on Twitter. I can also be emailed as jack@pusher.com. Some final closing thoughts. I think universal JavaScript is here to stay. I expect the techniques and libraries and approaches to change over time. If I did this talk in 12 months, if Andy has me back yet again, I'd probably do a very different slide deck and the code will look pretty different. But I think we're kind of getting there. With React and Ember and Angular, and I think Vue.js might be working on it, all the rest of them kind of all going in this direction, I've no doubt that we'll improve our approaches, and when one framework figures something out, that will kind of come through to the others as well. And kind of the goal here is that as developers, we should be able to get this working with very little effort. And that is the direction we're going in. Ember Fastboot, will kind of do it all for you. Angular 2 Universal should do a lot of it for you. And as you've seen, React does make it pretty straightforward too. Long term, I'd love to see frameworks go server-side by default, and it kind of be the baseline that a new JavaScript framework, of which there are already 10 or so out since I started, will kind of be server-side by default and just kind of work. And hopefully we'll get somewhere towards that soon. But you know, GoCarlist was a site that we used it on. There are loads of sites now using it as well. I think Packed Coffee, we've probably all come across, they use this same approach too, and they've had a lot of success from that. Loads of people are doing this, so you know, there'll be a lot of advancement in this area. So final links, that's the blog post on 24 Ways. There's a blog post by my former colleague Jamie on how we built the new GoCarlist website from whenever it was. The actual source code to the GoCarlist site is entirely freely available, at least it was, I think. I'm pretty sure it still is. And that's a link to that. And then the example application on GitHub as well. It wouldn't be a talk at a meetup if I didn't do a plug. If you want to do more React or you'd like to learn more about it, I'm doing day-long workshops in London. Sorry, a day-long workshop in London. So there's still tickets available. It's on the 10th of June, so it's not too long away. It is south of the river. It is in Elephant and Castle. But if you can bear that, there are tickets available. Wasn't my choice of venue. So thank you very much for listening. I hope that was useful. I'm Jack_Franklin. JavaScriptPlayroom.com is my blog. I will put the slides onto SpeakerDeck, so you can find me there. And if you have any questions when you wake up tomorrow morning about React, life, or anything else, or Rafa Benitez staying at Newcastle, jack@pusher.com is where you find me. So thank you very much for listening.